Hello, this is Jonathan Clow, and I'm going to go through some of the answers in the Getting Started with the DMMT tool tutorial. So the first thing we need to do is get a copy of the DMMT, and one simple way to do that is to just go and Google SLAM. Then it's the first item you see. There's a SLAM web page. Up top is 2015 project page. And navigate to the Dynamic Marsh Management tool. There are a number of sections here, but we want to get the New York download. So I'm going to click on the New York Dynamic Marsh Management tool. It will download pretty quickly. It's not a very big Excel file. And then click on that to open that up. And it is an Excel spreadsheet with Visual Basic that's running behind it. And so the next thing that you will have to do if you're going to work with this is to enable editing your Excel file. So click on that. Okay, so it opens up with an instructions page. You can also download the same set of instructions as a PDF, which helps to print or with multi-monitor systems if you want to work with one and the other. So let's go back to the understand current results. So the first question that it asks is to, in the Model Inputs tab, so you can click through to the Model Summary tab. Gives you some information about your setup. You've got the different adaptation scenarios are defined here. This is their nickname, and then there's some details about how they were modeled down here. Also just gives you some information about the sites that are being modeled and the historic loss inputs that are in there. The Model Inputs tab, these are the results that we put together for the New York City case study from the Survey Questions tab, which is just provided for information. You have all of the ecoservice relative ranks here. Horizontally, you have your site-specific weightings are vertical. And if you scroll down, you have a discount factor if that's relevant to your application. You have adaptation strategy costs down here, and then down here, the loss rates and whether you assume that they're going to be additive to sea level rise losses or not. So the question is which sites, in terms of the currently model that exists currently, have the most possible wetland benefits in the modeled time period. So the first thing we're going to do is we're going to go over to the survey questions. I mean, the model outputs is the next tab over. And you have, these are the raw outputs from the model, but they can be useful sometimes. It shows you for each site and each adaptation strategy, there's a run identification because you can store multiple runs for a reference, and it gives you a sense of the overall utility. So you can sort these by the overall benefit descending, and you get a list of which sites have the largest and site strategy combinations have the largest utilities. So when the sites are sorted in this manner, you can see that Idlewild and W.T. Davis have the largest utilities that are suggested overall. Now, if we want to take a look, and you can unhide results by utility up here, and this gives you a lot of additional data. So this is the overall utility, which is the sum of all of the individual utilities that are added up together. And the second question asks you which site provide the most benefit for underserved communities. So you can see under recreation and human use we have natural areas for underserved communities. It's really the highest benefits are in lines 17 through 19, which are Idlewild, inner and outer. So W.T. Davis has the highest overall utility by a small amount, but in terms of underserved communities, it looks as though Idlewild, inner and outer has the highest. Okay, moving on to question 1D. It says, in the Ecosystem Service Benefits tab, examine the components of each site's utility. So I'll go to the Ecosystem Service Benefits, and you can see the components of each site's utility are listed up here in the upper left. So the first question is, what is predicted to be the largest component of wetland benefits from the Idlewild site over the time period modeled? And you can see it's this pink bar is awfully big here. Habitat connectivity. Probably the second piece, you can see flood vulnerability is about 2,000. Next-in habitat is about 2,100. So it's habitat connectivity and next-in habitat, but flood vulnerability reduction is a close third place. Then the question was for Lemon Creek, where it's a little more obvious. Flood vulnerability reduction has the largest benefit there. Now I'm going to move to question E. Look at utility by site over time. So if you scroll over to the right here a little bit, you can see this is the utility by site over time. The average utility at the start is 100, and so you can see 2 sites have higher than average utility for the sites, and 4 have lower. And you can select the strategy that you're looking at. We're looking at no migration here. And you can even select individual utilities, which we'll be doing in a couple of minutes. So the question at 1E, 1, is which sites are predicted to lose the most benefits due to sea level rise over the time period? And you can see that the largest sites have the highest utility, but they're also predicted to lose the largest amount of utility over the time period. So this assumption here is for no migration. Let's take a look at a different assumption. Let's allow migration to all dry land, in which case you'd expect there to be more utility over time. And the question is, what happens to the utility for Alley Creek? And you can see it increases quite a bit. Marsh, some of the existing marsh is going to be retained, and there's going to be some new marsh colonizing dry land by 2100 in all likelihood. Finally, it says if you change the utility examiner to look at flood vulnerability reduction only. So let's take a look at that. Here are all the utilities that were defined, all the ecosystem services. So we change that to be flood vulnerability reduction. And the question is, which site provides the most utility by 2100? And in this case, Udall's Cove actually gains enough width that it's expected to have a higher utility than all the other sites. So the next thing we're going to do is look at the expected value land cover data. Oh, I'm sorry, actually, look at utility by strategy over time. And what this does is you have a single site which you've selected here, and in this case we've selected Idlewild, inner and outer. And it will look at all the different strategies for that one site. So in this question is, does marsh restoration to 1974 boundary or thin layer deposition seem a better strategy? And you can see over time the restoration to 1974 gives you a bigger benefit up front, as you would expect, but the thin layer deposition only has a very small marginal benefit, whereas there's a longer term benefit for marsh restoration that's predicted by this model, given this set of assumptions. Now we're going to look at the expected value for land cover. And the question is, let's look at this for W.T. Davis under the no action strategy. So you can select the strategy. It says no migration, so that's the same as no action in this case, or our base case. And let's take a look at W.T. Davis. Select that out of the list here. And the question is, what is expected to happen to the site's low marsh, and what about the high marsh? So we have the salt marsh, which we also call low marsh sometimes, regularly flooded marsh. That actually increases over time. The high marsh decreases quite a bit. There's the expected value at each time step. So this actually represents, for the year 2100, many dozens of simulations run under an uncertainty analysis. And the low and the tidal flat also is expected. You're expected to lose that given uncertain sea level rise. So the next question is to look at this vertical axis here, which shows that we have about 250 acres of wetland at the start of the simulation. And now let's switch to Udall's Cove. And you have about an order of magnitude fewer wetlands at that site, which is part of the reason why overall it has a lower utility, maybe a higher utility per marsh in some for some items. And the question is, are marshes predicting to increase or decrease at Udall's Cove? Again, we're looking at the strategy with no migration, and it looks like they're staying roughly the same, but decreasing somewhat. And then also, we have tidal flat being lost. And now, if we switch to a strategy of restore to 1974, you can see that we've actually increased our salt marsh at the beginning of the simulation quite a bit, because that restoration is assumed to occur at the beginning of the simulation period. The next thing we're going to do is to move to the adaptation strategy benefits, which looks at the comparative benefits of the different adaptation strategies. So this first graph to the upper left shows the comparative incremental benefit of adaptation strategies by site. So if you allow migration to all dry land as compared to not allowing any migration, these are the amount of additional utility benefits that you would get for on a site-by-site basis. So Alley Creek in Queens actually has the highest potential for marsh migration to developed and undeveloped lands. Under restoration to 1974, Idlewild Inner and Outer has the highest potential benefits, and thin layer deposition is not predicted to have very high benefits overall, but Idlewild has the highest potential for wetland benefits. The next thing it asks us to do on section J is to move to the current versus future utility chart, which is at the lower left of this screen. And this is a somewhat complicated graphic. What it really is designed to do is look at the difference between the utility in 2016 and the utility in 2100 with no action first. So you can see for a number of these sites, it drops off quite a bit. Then incrementally, we add adaptation strategies on top of that. So the next bar here is allowing migration to undeveloped land, and the next one allows migration to developed land as well. Then we have thin layer deposition, and then we have restore to 1974. So the question is, what needs to be done in order to maintain utility at the level that we have at the current time in 2100? And the question that's posed is, based on this run and these assumptions, for which sites can the combined adaptation strategies potentially mitigate sea level rise losses by 2100? And the answer is all of them, because when you look at this, basically looking at all of the adaptation strategies together in 2100, it's in all these sites, given this set of model assumptions, it's higher than the current condition utility. And the next question, part 3, says, for Idlewild, which adaptation strategies would be required to break even in 2100 as compared to the 2016 wetland benefits? So you can see there's no action as the second bar. So migration to undeveloped almost gets you to break even, but to migration to all dry land would get you beyond that. Now this is just based on this particular and arbitrary application of adaptation strategies, this particular order. There might be some other orders that could also get that done. The next question asks us to look at the estimated wetland benefits per unit cost graph. This graph shows you the amount of utility units that you would get per unit cost, in this case, per $1 million spent. And you can look at it across the different adaptation strategies. And so the higher bar gives you the higher utility. Now, one thing, using Excel gives you a lot of power, but it's not always the most user-friendly interface. So one thing I'm going to do is I'm going to left-click on this axis. I'm going to format that axis and set the axis to automatic because some of these bars were off the chart. And the question is, which combination of adaptation strategy and site will give you the 3 best benefits for cost? So if you had a certain amount of money to spend, where would you spend it first? Now, it's an interesting point here. Pelham Bay Cove actually, because all of the undeveloped land there is already owned by New York City Parks, the benefit per unit cost is infinite, so it's not showing up here. But if we look at the ones where we do have some cost considered, we have the migration of all dry land at Pelham Bay Cove, migration to undeveloped at W.T. Davis, and then restoring marsh 1974 at Udall's Cove is the third best thing you can do in terms of bang for your buck. And the one point is that you'd have to really spend a little bit of time pinning down these costs in order to get this. We did a moderately complicated job in terms of trying to break down public versus private costs and estimated costs. But if you really wanted to get a sense of where you're going to get your biggest bang for your buck, you could then go in and look at this on a parcel by parcel basis, see who's selling, what's public, what's private, what the actual cost of restore. You can refine this quite a bit. And that is a basic drive through most of the important parts of the model input in terms of understanding the current results, model outputs that are available for you. So now please continue on to section 2. See if you can get the answers, and then you can watch this another video about how to change model inputs and assumptions and see the effects they have on model results.